All right, let's jump right into this. We're going to break down the 5 absolute foundational principles you have to master before you even think about picking up a tool to work on heavy vehicle hydraulic and air-over-hydraulic braking systems. This is the stuff you got to know from day one. And that's a serious question, because working on these systems, it's not just about spinning wrenches. It's about safely managing some really immense forces. Your most important tools, way before you even open the toolbox, are your knowledge and your commitment to safety.
So let's talk numbers for a second. 1,000 newtons. That's enough force to be fatal, and it can be coiled up inside just one single spring brake chamber. Understanding how to identify, respect, and control this kind of energy is, well, it's absolutely non-negotiable. It's the starting point for everything else we're about to cover.
So that brings us to our very first principle, and honestly, it's the one that everything else is built on: safety. Before you even start thinking about what's wrong with the vehicle, you must secure the work environment. Let's talk about how to manage the unique dangers of these powerful systems. This slide really breaks it down perfectly. It shows you the direct link between a risk and how you deal with it. On one side, you've got the hazards, that stored spring energy we just talked about, high-pressure air, nasty brake dust, and regulated fluids. And on the other side, the non-negotiable solutions, things like correct caging procedures. And what that means is mechanically compressing that spring before you even think about removing it. And then system depressurization and proper control and disposal protocols. For every single danger, there is a specific required action. And I want to be super clear about this. This isn't just some boring paperwork you have to tick off. These are explicit knowledge evidence requirements for your qualification. Following them protects you, it protects your colleagues, and yeah, it protects the environment. It's really the bedrock of being a professional. Okay, so once you've made the area totally safe, what's next? Well, principle number 2 is all about the blueprint. Your first move isn't to grab a wrench, it's to consult the official documentation. Think of it like trying to build a house without the plans. You just can't do it right. And this quote right here, it just says it all. I guess isn't good enough. It looks okay is definitely not good enough. The manufacturer's specification is the one and only authority. This is exactly why knowing your numbers and being able to read this technical data are absolute core skills for this unit. And yeah, we're not just talking about looking up one single document. You need to be able to find, read, and then apply information from all of these sources to do a compliant and safe repair. You've got the manufacturer specs, the component tolerances, those super important Australian design rules, your own workplace job cards, and then, of course, the final repair documentation you create. All right, so the scene is safe, you've got your blueprints in hand. Now we get to the fun part. We need to actually understand the machine itself. We have to really grasp the fundamental operating principles of the system we're working on. So what is it? It's this really clever hybrid system. It uses the raw power of compressed air to push on a hydraulic master cylinder. It's a design that brilliantly combines the massive force you can get from pneumatics with the pinpoint accuracy and control of hydraulics. It's how you stop a massive, heavy vehicle. And listen, this right here is probably one of the most important things to remember when you're diagnosing a problem. A simple issue with air pressure or maybe a faulty air valve can create symptoms that look exactly like a hydraulic leak or a bad master cylinder. If you get that wrong, you're going to chase your tail and fix something that was never broken in the first place. Okay, on to principle number 4, which I like to call the hunt. With our safety checks done and blueprints ready, we hit the diagnostic phase. This is where you put on your detective hat. Your mission is to follow the clues, step by step, to hunt down the single root cause of the problem. So a driver comes to you and says the brakes are pulling to one side. You've probably heard this a dozen times, right? But the answer isn't simple. And for a professional technician, just guessing is never, ever an option. You've got to investigate. And what's so interesting here is how this one symptom could point to so many different failures. So what could it be? A seized caliper? Maybe. Contaminated brake pads? Could be. Or what if it's not even hydraulic? Could it be unequal air pressure? Or a faulty proportioning valve? Or worn-out germ parts? You see, you just can't know without testing. This is your roadmap. A structured, logical sequence is the only way to correctly figure out what the real problem is. You start with a physical inspection of all the bits and pieces. Then you test the air system, then the hydraulic system, then you do some operational tests, and finally, you measure everything and compare it against the specs. You have to follow these steps. It's the only way. And that brings us to our 5th and final principle, the proof. Look, a repair is not done just because you bolted on a new part. It's finished when you've proven the entire system works correctly and safely under real-world conditions. And you have to perform both of these types of tests. So you've got stall testing, that's to make sure the brakes will actually hold the truck on the hill. Super important, right? But then there's dynamic testing, because a brake that works when you're standing still might not be good enough when you're moving with a full load. Dynamic testing verifies the brake's performance out on the road. And let me say this again, because it's that important. This isn't just a good idea, it's an explicit performance criteria. You haven't finished the job when the new part is on. You've finished the job when you have completed these tests and proven the repair is effective. This is what separates a professional, compliant repair from one that's incomplete and potentially really unsafe. So that really brings us to the big question, doesn't it? The ultimate takeaway is this. Your work is only finished when you have proven, through structured testing, that the braking system is not only functional, but also safe, compliant with all regulations, and 100% ready for the road. That's the professional standard, period.